we will discuss about binary arithmetic operations. We have binary addition, binary subtraction, binary multiplication, and binary division. Binary addition can be performed by using the following rules. 0 plus 0 equals 0. 0 plus 1 equals 1. 1 plus 0 equals 1. 1 plus 1 equals 1, 0. Where 0 represents the sum value and 1 represents the carry value. So let's try to solve some problems. For our first problem, 1 0 1 1 0 1 plus 1 0 0 1 0 1. 1 plus 1 equals 0, carry 1. 1 plus 0 plus 0 equals 1. 1 plus 1 equals again 0, carry 1. 1 plus 1 1 plus 1 equals 0, carry 1. 0 plus 0 equals 0. 1 plus 0 plus 0 equals 1. 1 plus 1 equals 0, carry 1. 1 plus nothing equals 1. So that is the answer for our first problem. 1 0 1 0 0 1 0. Next problem. One 1001.01 plus 1001.11. 1 plus 1 equals 0, carry 1. 1 plus 0 plus 1 equals 0, decimal 1, carry 1. 1 plus 1 equals 0, carry 1. 0 plus 1 equals 1. 1 plus 1 equals 0, carry 1. 0 plus 0 equals 0. 1 plus 0 plus 0 equals 1. 1 plus 1 equals 0, carry 1. Enough na. That is the answer for the second problem. Binary subtraction can be performed by using the following rules. 0 minus 0 equals 0. 1 minus 0 equals 1. 1 minus 1 equals 0. 0 minus 1. So here we have to assume that is borrow value 1. So we can write 0 minus 1 as 1 0 minus 1. Here the difference is 1 and the borrow is 1. So let's solve some problems to understand the idea clearly. So here we have problem 1. 1 0 0 1 0 minus 1001. So 0 minus 1 cannot be. So we need to borrow from the previous bit. We need to borrow from here. This becomes 0. This becomes 1 0. 1 0 minus 1 is 1. 0 minus 0, 0. 0 minus 0, 0. And again, we need to borrow since we cannot subtract 0 minus 1. We need again to borrow from the previous bit. This becomes 0 and this becomes 1. 1 0. 1 0 minus 1 equals 1. So that is the answer for our first problem. For our second problem, (110.01 minus 100.10). 1 minus 0 equals 1. 0 minus 1 cannot be. We need to borrow the value from the previous bit. Since we cannot borrow from here, we will borrow from here. This becomes 0. This becomes 1 0. And we need to borrow again since we cannot subtract these two values. Though this becomes 1, this becomes 1 0. 1 0 minus 1. So we can now subtract. 1 0 minus 1 is 1. Decimal value, a decimal point. 1 minus 0 equals 1. 0 minus 0 equals 0. 1 minus 1 equals 0. So the answer is 1.11. For our third problem. (11.01111) minus 10.01001. Let's start. 1 minus 1 equals 0. 1 minus 0 equals 1. 1 minus 0 equals 1. 1 minus 1 equals 0. 0 minus 0 equals 0. Decimal point. 1 minus 0 equals 1. 1 minus 1 equals 0. So this is our answer for our third problem. Binary multiplication is similar to decimal multiplication. Multiplication of binary can be performed by using the following rules. We need to remember that anything multiplied with 0 is equals to 0. So 0 times 0 equals 0. 0 times 1 equals 0. 1 times 0 equals 0. Whenever we have both values equals to 1, then we can multiply and get the answer. 1 times 1 equals 1. So let's solve some problems. (1 0 times 1 1). 1 times 0 equals 0. 1 times 1 equals 1. 1 times 0 equals 0. 1 times 1 equals 1. Now let us add. So 0, 1 plus 0 equals 1, and then 1. So this is the answer for our first problem. As you can see, it is similar to normal multiplication. So next. So as you can see, we have fractional numbers, and in case of fractional multiplication, we have to multiply for the we have to take the multiplication for the whole binary number without the decimal point. So after getting the answer, we are going to make the decimal point. So 1.01 times 10.1 is going to be 101 times 101. 1 times 1 is 1. 1 times 0, 0. 1 times 1, 1. So 0 times 1, 0, 0. 0 times 1, 0. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. Now we are going to add. One, 0 plus 0, 0. 1 plus 0 equals 1, plus 1 equals 0, carry 1. 1 plus 0 plus 0 equals 1. So 1. After getting the answer or the result, now we are going to make the decimal point, which is the sum of these two fractional parts. So 1, 2, 3. So from right, we move to the left. 1, 2, 3. So here we will put the decimal point. So this is the answer for fractional multiplication of binary numbers. So next problem. 1011 times 110. 0 times 1, 0. Because anything multiplied with 0 is equals to 0. 0, 0, 0. 1 times 1, 1. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. Again, 1, 0, 1. So now we will add 0, 0 plus 1, 1. 0 plus 1 plus 1 is 0, carry 1. 1 plus 0 equals 1, plus 0 equals 1, plus 1 equals 1, 0. So 0, carry 1. 1 plus 1 equals 0, carry 1. So 0 plus 0 equals 0. 1 plus 1 equals 0, carry 1. And 1. So this is the answer for the third problem. Binary division. Division of binary numbers is similar to normal division. Binary division can be performed by using the following rules. 0 divided by 1 equals 0. 1 divided by 0 equals infinite. But in case of binary, there is no meaning for getting the infinite value. So we are not using this rule. One divided by 1 equals 1. 0 divided by 0 equals no meaning. So we will not be using this rule. Now these are the rules we are using in binary division method. So we will have this problem here. 1 0 1 0 1 0 divided by 1 1 0. We will start the division from the leftmost bit, the most significant bit, which is this one, the number 1, the bit 1. 1 is less than 1 1 0, so we will have the quotient as 0. 0 times 1 1 0 equals 0. So subtract, we will have remainder 1. So bring down 0. 1 0 is still less than 1 1 0. So we will still have the quotient as 0. 0 times 1 1 0 equals 0. Subtract, and remainder 1 0. Bring down 1. 1 0 1 is still less than 1 1 0. We will still have quotient as 0. 0 times 1 1 0 equals 0. Subtract, and remainder, we will have the remainder 1 0 1. So bring down 0. 1 0 1 0 is greater than 1 1 0. We will have the quotient as 1. 1 times 1 1 0 is 1 1 0. Subtract 0. 1 minus 1 is 0. 0 minus 1 cannot be, so we will need to borrow the value from the previous bit here. So this one will become 0. This one will become 1 0. 1 0 minus 1 is 1. So we will bring down the 1. 1 0 0 1 is greater than 1 1 0.
Dito kami matutulog, ha?
So we will have quotient as 1. 1 times 1 1 0 is 1 1 0. Subtract 1 times 0, 1 minus 0 is 1.
Dito ba ako
0 minus 1 cannot be, so you will need to borrow from the previous bit. Since you cannot borrow from here, it's already 0. We'll borrow from here. This will become 0. This will become 1 0. We still cannot subtract 0 and 1, so we'll borrow from here. We can now borrow from here. This will become 1 and this will become 1 0. 1 0 minus 1 is 1. And 1 minus 1 is 0. 0. Bring down. I'm sorry. Now bring down 0.
Walang pressure, no expectations. Saan pwede ka buhay at walang tatawa sa iyo.
1 1 0 is equal to 1 1 0. So we have quotient as 1. 1 times 1 1 0 is 1 1 0. We will subtract, we will get the value 0. Now we have completed the division and the quotient is this. So you can neglect the 0 because it will make no change. And the answer is this one. So, answer 111. That is the answer for this problem.
So, hexadecimal number system, arithmetic. In addition, here are the given example. 582 base 16 plus 432 base 16. 582 plus 432. So, 2 plus 2 is equals to 4. A plus 3 is equal to 13 because the A is correspond to 10. 13, so carry 1. 5 plus 4 is equals to 9. Plus 1, it is equals to 10. So we put A here because it is correspond to 10. And that is the answer. So in subtraction, here are the given example. 6A3 base 16 minus 5B4 base 16. 6A13 minus B 5B4. So 4 minus 3 it cannot be subtract because the numerator is smaller than the denominator. So let's borrow to the second number, which is A, and it is correspond to 10. So 10 is, let's borrow to A, so it becomes 13. So 4 minus 13 is equals to 9. So 9 minus 5, it is equals to 20 because because B is corresponds to 11. Then A is correspond to A. But we borrow here for the first number, so it becomes 9. So yeah, A minus B is equals to 20. 6 minus 5 is equals to 1 plus 3, it equals to plus 6 minus 5 is equals to 1 plus 2 equals to 3. So the answer is 309 base 16. So let's move on to multiplications. These are the given example. 15 base 16 times 23 base 16. 15 times 23. So let's solve this. 3 times 5 is equals to 15. We put F here because the 15 is equivalent to, is correspond to 50 F. Then 3 times 1 is equals to 3. Then we move to the second number. 2 times 5 is equals to 10. And we put A here because 10 is correspond to A. 2 times 1 is equals to 2. Then let's multiply again. Then F, bring down the F. Then 3 times 10 is equals to 30. Then 3 times 2 is equals to 6. That's the final answer.
So now what we're gonna do is the division decimal. So here are some examples. If the divisor is a decimal and the dividend is a whole number, we can still solve this. So the only thing we're gonna do is that put straight up the decimal point here. Don't forget it. Just put straight up the decimal point. So we got the answer 0.28. So what if both the divisor and the dividend is decimal numbers? So example is 1.5 and 6.455. So what we're going to do is to move the decimal point to the left here, like that. It's the same thing, we're gonna move the divisor to the right, so that we will get the whole number 15.15. So the decimal point is 64.5. So the only difference here is that we move the decimal point to the right with the same in the dividend and in the divisor. Even though we move this, we will still get the same answers. The same answer for 4.3. But with this, we just make the problem or the solution, to get the solution much easier just by moving the decimal point. So that's all. Thank you. So now we're going to do the decimal division. So here, example, we have the dividend is a decimal and so now we're going to discuss about multiplication decimal. So here's the example. With this, we will find hard time to answer. So what we're gonna do is to pretend that the dot or the decimal point is not there, so that we will get the whole number. Okay, we will write it. I mean, the whole number is there, but it moved right up to here. So since there's no point, we will not put the 0. So now we will multiply, or we can multiply the number. So there's still missing one. We forget something, the decimal point. So we'll count how many times the decimal point have moved. 1, 2, 1. So we will add how many times the decimal point have moved to the up and down. So it moved 3 times. So we'll move it to the left 3 times. 1, 2, 3. So the decimal point is there. So the answer is 18. If we multiply the 3.65 times 2.4, the answer is still 8.760. And why the same answer goes when we multiply this? Because we move the same number, the same amount, the same number, decimal point. So that's all.